Hello, in this tutorial we are going to present how to perform a simple box building using GMatrix software. First I go to the icon, I run the software, the graphical interface will open first, then I'll go to upper menu, I'll choose Matrix, start Matrix Classic, and then another menu will open. I'll go to File, I ask for New, I have 3 extensions, I select the BIM. I'll start by writing my quotation number, job number, project number, and the following information: building area and revision. Then the most important, I go to building parameters. In the building parameters, I will define the work order form of that of the project or of the building. So I start by inputting the building width in meters from out to out, left eave height, left eave height, right eave height, sorry, ridge distance from the left side, ridge height, level from the ground, and I'll keep it 0 for now. And then I'll go to the base spacing to define the number of bays dimensions which define finally the length of the building. So it's very important to highlight that the first bay and the last bay shall be given only as one bay, and in between I can make I can make the following writings. So by putting my mouse here, I can read an example. I can say 5 at 7, 2 at 6, and then 2. So always we realize that the first bay and the last bay shall be given as only one bay. In this example, I have the first bay is 5, second bay is 6, then I have one bay at 7. It can be 3, for example. Type of frame, I have different type of frame: rigid frame, which is a clear span, BC1, BC2, BC3, BC4, that define the multi-span. So I'll start by the rigid frame that is a clear span. I write RF, wind column spacing from left to right. I put each wind column spacing relative from each other. So the first column, wind column, is at 5, the second wind column is distant from the previous one of 5 meters, and the last one is distant of 5 meters. And I repeat, this is a wind column distance, and it is not the module, the base spacing, the base spacing and transverse direction module. Bracing location, so it should be at which bay? At bay number 2 and bay number 5. Purlin arrangement, I have to write here the current purlin spacing that I'm going to select 1.5. I have to put from which distance this purlin must start, and then the balance will be calculated automatically by the software at the left side and the right side. Same thing for the girth. Then at 6, what does it mean? So this means that I want to divide the rafters every 6 meters. Base plate condition. So here I will define also what is the base plate condition that I want to work based on. And this depends also upon the expertise of the engineer. So it can be usually 250 millimeters, it can be 300, 400, 500, any number I'm going to choose here. So let's keep it 250 at this stage. Then I'll go to the frame at the bottom. I want it to be pinned or fixed. So practically it should be pinned, which is the optimum solution. I want this building to be light end frame or not. I have to select yes or no. In this case I'm going to say yes. Coming to the gravity load, very self-explanatory. dead load that represent the weight of the purlin and the weight of the sheeting per kilonewton per square meters, that is 0.1. Frame live load on the roof 0.57, purlin live load on the roof 0.96, collateral load 0, snow load, which is actual snow load weight that I'm going to use on the roof. Temperature, it can be between this value and that value. Wind speed in 3-second gust 130 kilometers per hour. Importance factor, we can select 0.87, 1 or 1.15. In this case I'm going to say 1. Opening condition, it can be enclosed, partially enclosed or open. And of course, if I'm going to change the design, the building code, if I used ASCE 2016, so then in that case I have to select enclosed, partially open or open. So we can see that the menu is dynamic with the minimum building code that I'm going to use. Wind exposure, it can be B, C or D. In this case I'm going to say C. Seismic spectral motion acceleration, S sub S and S sub 1, I enter them. Importance factor, again it's according defined according to the code. Soil classification as per code requirement. R factor 3.5, long period is 4. Left end wall opening, so for block work, this means that I need to have block work on the left end wall at 3 meter, right end wall at 3 meter, near side wall 3 meter, far side wall 3 meters. Now on the plan we're going to see what are these left end wall, right end wall, near side wall, far side wall. Steel line, then I will define what is the distance from the center of the column at the end base to the steel line from the left at the left end wall and the right end wall. Roof sheeting, from the library I have to select the type of the sheeting. If I have mezzanine deck, I have to select the mezzanine deck. End wall gird, it can be flush or bypass, it's much better to keep it as bypass. Side wall gird bypass, roof purlin bypass. Design code, I may select from the list AISC 2005, 2010, ASD, LRFD, AISI 2016, EC3 and IS 800. Building code ASC 7-05, also from the list I can select. Frame F-yield 345, purlin F-yield 345. Connection bolt is according to ASTM, it can be A307, that is grade 4.6, A325 grade 8.8, A490 grade 10.9. Anchor bolts, same thing, it can be grade 4.6, 8.8 or 4.9. Minimum plate thickness, in case I have a requirement for a minimum plate thickness, I can add it here. Keep it 0 and it will take the minimum as per my library. Minimum Z section to be used. I have the list of the Z section that I can select from. Minimum C section to be used, also same here. I'm going to select 200. Then I have to save the information, and my project name is automatically given as project7.bim. Next page is for the crane, will come at a later tutorial. Mezzanine, also same thing. Then the main menu here, the most important is edit. The edit menu, I'll start by generating every item. So this line is for the frames, this line for the purlins, side girds, end girds, wind columns, and bracing. So I'll start by generating my frames. Then the purlins, girds, and girds. Then it gives the message that no need for wind column because the wind columns have been merged with the end frames in order to perform a frame, a BC frame with wind columns. To generate the bracing here, So I have the following options: cable, rod, angle, double angle, and tubes. So I have for the walls as well as for the roof. In our case, I'll keep it as a cable. And we realize here that before generating this frame, I have to check and make sure what will be the maximum stress ratio that I want GMatrix to work based on. These two will come later on. I'll save. Then I start by running the auto design of the frames of each item separately. Now frame number 1 optimization has started. Frame number 2, as we can see here. Frame number 3. Four. Frame number 8, because 4, 5, 6, 7 are similar, or 7 is similar to 2. Frame number 8 here. Now the optimization has been done for the frames. I'll run the purlins, girths, and the bracing. I'm going to save my results. The edit button here is very important and flexible option to allow me to see the frame text file, the syntax. So this text file script, it represents the structural model and the result that I have end up after the optimization. So it starts with the title, print is to print the output, material A, the type of material A, type of material B, with the type of the bolts, design code, direct analysis method, P delta and P delta analysis has been done. The ratio to respect is 0.95, not the coordinate X, Y, and Z if I have to. Member CL, incidence from 1 to 2, tapered, so on, and the division. This will come in a different tutorial. Support conditions, releases, load case, load combinations, connection types, and the pin base. From the edit menu here, I can control the number of the bolts that I want to use for each connection. Okay, for example, I can change this one to 6 instead of 4, and the software will keep this to me to control the number of the bolt for each connection that I have to use, and he will optimize the thickness of the plate and the diameter of the bolts. Same thing for other frames. Let's see frame number 2 or frame number 3. We can see how it is tapered. Example, I can see here 550 and 450. I want to keep it 550. So whatever I write here will be considered by the software. Frame number 2, save yes. Same thing, because it's following the moment diagram and the mode of failure. It starts with 250, 500, and then 450. So I'll keep this one as 500 instead of 450. So I'll keep it straight from the top. So I did this for the first, second, and third frame. And then if I made a change at frame number 1, I can copy it to frame number 8. I don't need to do it this time because I did not make any changes, just only for an example. if I want to copy frame number 2 to frame number 7, I can do it that way. Frame number 3, I want to copy it from frame number 4 to frame number 6. So 3, 4, 5, 6 will become identical. I move on, save. Here for the Berlin, it will show me the selected sections. Next page, I'll go to the generate plans. I'll press on generating the plans. I have the option to show or to hide the sections. AutoCAD is opening now, running. Then here we go, the general notes, specifications, anchor bolts, left end wall elevation, anchor bolt plan, right end wall elevation, roof framing, connection, standard connections, frame cross sections, left side wall opening, left side wall elevation, sorry, right side wall elevation showing the sheeting. Still writing here the frame cross section with the column reactions required for the contractor to design his foundations. Let's take a closer look. This is the first page. As we can see, the loads that I have applied came automatically to this page. If I have other items, they will be visible here. Project name, I did not write any. List of plans, A00, A01 to A17. This one is general notes. Anchor bolts with details, left end wall elevation, anchor bolt plan, left end walls, left side wall, near side, far side wall, and this is a near side wall as we can see here in the title. Roof framing with the bracing and the sizes, with the eave strut and Z sections. Standard connection details, and here we go to the frame cross section. We can see the frames and the connections, and of course the connection of the frame, I can, from the edit menu, I can control the location and the number of the bolts. So we can see the tapering, the difference between the top flange and the bottom flange, column reactions, and this one is from 10 to 17. I save my results. I go to the bill of material, create BOM, I'll wait for the progress bar to finish till the end. Excel is opening now. If I move remove this menu, then I can see that the progress bar has not been completed yet, so I have to wait. Let's not disturb Excel while working automatically and interacting with GMatrix. Now it's completed. I can maximize my Excel sheet. Material ID, member ID, material ID size, weight per kilograms, area in square meters, length, number of bolts, diameter of the bolts, and ERP code. Then for each item I can see the bracing, accessories I have none, bracing 1, bracing 2, crane beams I don't have any, crane brackets none, mezzanine deck none, end girds, flange bracing, frame number 1 and 8, frame number 2 and 7, frame 3, 4, 5, 6, purlin number 1, roof sheeting, side gird, trims, wall sheeting as described, and then I can see here the total weight of the building per square meters, painting area, which is a very helpful tool, especially when we have a project with a special paint. Then the breakdown will be the heavy steel, GI coils, roof sheeting in square meters, wall sheeting in square meters, trims in linear meter. And by this I have defined and automatically designed completely a simple box building from work order form to approval drawing to bill of material. On the other page, the category, it writes for us for each member the category of that member, and it will give me the weight per linear meter for each member that allows me to define in more accuracy the cost fabrication, and this is related to each fabricator. Thank you for now. We'll see you again in another tutorial.